This is section 4.4, oxidation reduction reactions, and these are reactions in which one reactant transfers electrons to another reactant. So someone takes electrons and someone gives them. And there are names for the takers and the givers. Oxidation is losing or giving away electrons. That's losing electrons is oxidation, Leo. Reduction is gaining electrons, or gaining electrons is reduction. And my little mnemonic for memorizing this is that Leo, the lion, says grrr. Some people use oil rig. Oxidation is losing. Reduction is gaining, so that would be OIL for oil, RIG for rig. You can use whichever one you would like. Then there's some confusing vocabulary, because first we have oxidation reduction, then we have these things called agents. A reducing agent is the substance that got oxidized. So you're just learning what oxidation is, and now you got to understand that the agent that's the reducing agent is the one getting oxidized. The oxidizing agent is the one that gets reduced. An agent is the one who does something to somebody. So if you're the oxidizing agent, you're not getting oxidized, you are oxidizing somebody else. So you do it. This is very important. Okay, so now assigning oxidation numbers. An oxidation state is just another name for an oxidation number. These numbers or states, it's just a way to keep track of electrons in redox reactions. It doesn't have a true significance other than it's like record keeping. So here are the rules for oxidation numbers, and we follow these rules in the order in which these are given. So if a rule below another rule contradicts a rule above it, we go with the rule above. Okay? Right there. So we're going to try some using these rules. So we have aluminum. Rule 1. All free elements have an oxidation number of 0 unless they are ions. Well, there's no charge showing here. So that's a free element. Therefore, it has an oxidation number of, 0. Okay, Al plus 3. It's not a free element. That's an ion. It is an ion, so this doesn't work. Monatomic. Mono means one. Atom is an atom. So single atom ions. Ions are things that have charges. This has a charge, and it is one atom. So this is a monatomic ions. Have the oxidation number of the charge of the ion. So you should know what this one is before I show you. It is 3. All right. Next one. Oh, now we're getting complicated. We've got a whole compound. So let's look at this. We got free elements, got a compound, that's not going to help. Monatomic ions, not going to help right now. It sort of helps. The oxidation numbers of all compounds must add up to 0. So we're going to make this total all add up to 0. Now, we need to recognize that this is an ionic compound made up of magnesium ions and phosphate ions. So we've been seeing these ions for a while, working with charges, and we know what the charge of an Mg is when it's by itself as an ion, not part of a polyatomic ion. And we know, because this is ionic, these are Mg ions. So it says the oxidation number, where are we, rule 2, all monatomic ions have the oxidation number of the charge of the ion. Well, this doesn't look like a monatomic ion because it's in a compound, but it's made up of Mg ions, which are monatomic, and if you look up Mg, you will find it has a charge of +2. The P we don't know, but down here we know oxygen has an oxidation number of -2, except one of the other rules above contradicts this, and none of the rules are going to contradict this. For the most part, oxygen is always going to be -2. So each oxygen, notice I put each atom up on top, and I put the total down on the bottom. So each magnesium right here is +2, but I have 3 of those. So the total for the magnesium right here, the total is +6. know that total has to add up to 0. Oops, I don't want to get rid of that 6. Now, the total for the oxygen, each oxygen is -2, and I have 4 times 2. I have 8 oxygens. So 8 times -2 is what? -16. Okay, so putting the total for all of the atoms or ions down at the bottom, and each by itself up on top. So now, how do we get the P right here? Well, we know that the total here must add up to 0. And I ask myself, what must this number be in here to make this total add up to 0? Can you figure it out? We have to have a plus 10. So the total phosphorus, the total on the phosphorus has to be 10. So that 6 plus 10 minus 16 equals 0. We lost the 0. There we go. This whole thing has to add up to 0. So now the total phosphorus has to be 10, and I have 2 of them, because remember this 2 applies to everything inside the parentheses here. Well, if I have 2 times each phosphorus equals 10, then each phosphorus must be 10 divided by 2, or 5. And I made the O disappear. There we go. Okay, so this tells us that Mg is +2, P is +5, the O is -2. And notice we're putting each atom, not totals. I would not say that the Mg is 6. I say it's 2. I should put a little colon here. Okay. All right. Let's do the next one. Oops, there's supposed to be a minus right there. Okay. NO2, 1 minus. Your sheet might not have that minus on there, but it is NO2, 1 minus. So we look at our things. I don't have any free elements. I don't have a monatomic ion. It's not a compound because there was a charge showing. The oxidation number of all atoms in a polyatomic ion must add up to the charge of the ion. Notice I'm looking at the rules in order. So this monatomic ion has a charge of -1, so the total must add up to -1. I want to move this over a little bit. And any more information? Oh, here we go. The oxidation numbers of all atoms in a polyatomic ion. We just said that. Okay. There's no fluorine in here. There's no hydrogen in here. There is oxygen. So oxygen is going to be -2 because I haven't gone against that rule anywhere. So the oxygen will be -2. And the total on the oxygen, I have 2 oxygens, so the total for the oxygen is 2 times -2, which is -4. And this whole thing must add up to -1. So each nitrogen must be +3, because 3 minus 4 is -1, and we have to add up to that total charge. And I only have 1 nitrogen, so that lonely little nitrogen is +3. And then my final answer is, the N is it +3? And the O, it is not -4. We don't do the totals. It's not the totals. It's atom in the substance. So O would be -2. These would be our answers. So these are the oxidation numbers for nitrogen and oxygen in nitrate. Moving on. Okay. So we have a compound again. The total must add to 0. And we know that I don't have free elements. I do have some monatomic ions. You have to recognize this is ionic. It's got copper and nitrate ions. So Oxidation numbers must add up to 0. We use that. Okay, the oxidation number of all atoms of polyatomic ion must add up to the charge of the polyatomic ion. Well, we know we have nitrates in here, so the total of the N and the O3 are going to add up to the nitrate, -1, but we don't need that yet. Oh, oxygen, here we go. There's some oxygen in there. Well, we can at least assign that one. Let's assign our oxygen. We know that the oxygen is -2. Okay, now, tricky way to do this is we know nitrates by themselves are -1, and we have 2 nitrates. We've done this before with figuring out names from formulas. We can figure out the charge of the copper knowing that we have 2 nitrates. We have 2 -1s. If we have 2 -1s, we know the copper has to be +2. So I have the copper is +2, the oxygen is -2. Let's do our totals now, whatever we can calculate. So the total oxygen, let's see, I have oxygens are -2. 3 times 2, I have 6 oxygens times -2 is -12. Okay. The oxygens are -12, the coppers are 2, and I have only 1 of them. So the total in the copper is just +2. And the total on this whole thing has to add up to 0. So what does the N have to be? This total has to add up to 0. The total for the N has to be 10. Oops, that's not a 10. Move that over a little bit. Want everything to line up nicely. Okay. So, total for the nitrogen is 10, but I have 2 of them. Very important. So 2 N's equals 10, therefore each nitrogen is 5. Okay. To summarize, all right, here's our numbers for all the elements in this compound right here. Okay, next one. Compound, total has to add up to 0. Now you have to recognize this is ionic. Chromium, we don't automatically know the charge, but chlorine we do. So when we have an ionic compound, the oxidation numbers are just the charges of monatomic ions. So chlorine has to be -1. The total on the chlorines has to be -3, which means that the total chromium, since we have to add up to 0, the total chromium has to be +3. And I only have 1 chromium, so each chromium has to be +3. There you go. Okay, remember you put the amount for each atom, not for the totals. Okay, we've got a polyatomic ion, so the total has to add up to -3 if you look at your rules. And you can pause these at any time and do them all on your own. You check your rules. Oxygens are always -2. I can't do the phosphorus yet. Let's see, I have 4 oxygens, so 4 times -2. The total on the oxygen is -8. And the total down here must add up to -3, therefore P must be +5. And I only have 1 P, so each P must be +5. All right, number 8. Again, stop at any time and do these on your own. Polyatomic ion in here, ionic compound. We don't know Mn automatically, so we're going to have to use information about carbonates. Well, first we know oxygen. Oxygen is going to be -2. Oops, not -23, just -2. The total on the oxygens will be, I have 3 of them, so 2 -3s, 3 -2s will give me -6. And And the manganese, now I know carbonate, if I look up a full carbonate, carbonates are -2. It's not because of this -2 up here, it's because carbonates are -2. And the whole compound does add up to 0. So we could calculate the charge of the manganese. Since the carbonate must total -2, the manganese must be +2. We do this with naming when we have to find the charge of the metal, and we use the Roman numerals. And we have only one metal, so that metal's charge is +2. Now we can calculate the carbon, because this total must be 0, since compounds must add up to 0. So this carbon must be, you got it, +4. Okay, let's write our oxidation numbers over on the right side. There you go. All right, number 9. All right, so in number 9, we have a polyatomic ion, because the polyatomic ion is just poly, many, atom, many atoms in the ion. So polyatomic ion, we know it's an ion. It's an anion, a negative ion, and a negative ion. Okay, total must add up to -2. That's one of our rules. And oxygen, when it's not pure by itself, it is -2, unless one of the rules contradicts that. None of the rules contradict that. The total on the oxygens will be -2 times 3 oxygens, which is -6. And this whole thing must add up to -2, therefore the carbons must be +4. How many carbons do I have? Only 1. Therefore each carbon is +4. There you have it. Now write them out. And last but not least, number 10. Okay. Oh, these are getting tiring. Okay, oxygen. Always -2. Unless it's by itself, it would be 0, because that would be a pure element, like number 1 when we did aluminum. Above, remember the pure aluminum was 0. Okay, it's not pure oxygen, so -2. Total on the oxygens, 3 times 2 is 6, times -2 is -12. -12. Okay, this is an ionic compound. I've got a polyatomic ion right here and copper right here. To look up the charge of PO3, turns out to be -3, and I have 2 of those. So my total on the negative side, I'm just trying to calculate my copper right now in the way that we do it for ionic compounds when we're figuring out the charge for a Roman numeral. Same exact process. So phosphate ions, -3, and I have 2 of them. So the total here is -6. Okay, 3 of these must equal +6, because the negative side, remember I said it was -6? The positive side has to be +6. So 3 of these are +6, so each of these must be, what times 3 is 6? 2. +2. So each copper is 2. The total on the coppers is +6. So I've got 6 on the coppers, -12 for the oxygens. Therefore the total phosphorus, this total for everything must add up to 0. So what does the phosphorus have to be to make this add to 0? This is like 3rd grade math when you get to the math part. +6. Goodness, I've lost our equals 0. Okay, so now you have to recognize you have 2 p's, because this 2 here applies to all the p's, everything in, oops, like that. This 2 applies to everything in the parentheses. So I have 2 p's, and the 2 p's must add up to +6. Well, if 2 p's equals 6, each p equals +3. Oops, lost my other element over there. All right. So now let's put all of this together. And there you have it. These are our oxidation numbers for each of the elements in copper to phosphite. Okay, so last problem for this. We're going to identify the substance oxidized, the substance reduced, the oxidizing agent, the reducing agent. So this is getting back to this beginning here, oxidation and reduction. Okay, we just learned about how to assign oxidation numbers. Now we're going to apply that. So oxidation is losing electrons. If you lose an electron, your charge increases. So if your charge or oxidation number goes up, you are being oxidized. If you gain electrons, your charge goes more negative, you are reduced. Okay, so first we have to figure out all the oxidation numbers for all these things. Okay, let's go from the beginning. So let's see. Oh, C's and H's. We haven't seen any rules about H's yet. So we are told that H, hydrogen, compounds add up to 0, we know that, and hydrogen is +1 in all compounds except with metals. Carbon is not a metal. So this H right here will be +1. And the totals, remember we put the totals on the bottom, the total here will be 4 H's +4. That tells us now that the total for the carbon is -4, which tells us that each carbon is in fact -4, because I only have one of them, -4. Okay, then we get over to our oxygens. Up until now, you only seen oxygen as -2. But here I have pure oxygen by itself, so that is just plain old 0. I don't have to put any totals on the bottom. Okay, CO2, I know O is -2 when it's in a compound. And, oops, I have two -2s, so here I have a -4. Total in this compound must add up to 0, so I know that the carbon must be +4. Okay. And I only have one carbon, so each carbon must be +4. Okay. H2O. I have a rule about H's and I have a rule about O's. Let's see if they work. H's, if you look at your rules, your oxidation rules, let's see, H's, back to the rules, +1. Hydrogen is +1, oxygen is not a metal, so that +1 works, and oxygens are -2 in compounds. Let's see if this adds up to 0. By the way, you ignore the coefficients when you're doing this because the coefficients don't change your oxidation numbers. It just says you have more waters, not that the oxidation numbers of the waters are different. So H is +1. O would be -2. Did that add up to 0? Let's see, my totals here. I have 2 +1s, which would be +2, and I have only one O would be -2. -2 +2 is 0, so this works. Okay, now I have to figure out these pieces right here. So oxygen went from 0 to -2. That got reduced. Notice if your oxidation number decreases, like that word reduce, decrease, the oxidation number decreases. If your oxidation number goes down, you also gained electrons. Gaining electrons is reduction. So that's telling me the oxygen is reduced and is the oxidizing, that is getting hidden. There we go. And it's the oxidizing agent. Now, carbon, who else changed? Notice the hydrogens didn't change at all. They went from 1 to 1. They didn't change. Carbons, however, -4 to +4. So if you're going -4 to +4, oxidation number is going up. That means you lost electrons. If your charge decreases, it's because you lost electrons. Losing electrons is oxidation. So that tells us that methane, which is CH4, methane in fact is CH4, methane is oxidized, and whoever got oxidized is the reducing agent. Okay, we are done. Oops, now we are done.